Hello everyone. Today we're going to talk about simplifying fractions or reducing fractions to lowest terms. Why are we studying fractions? We have to study fractions because we're learning how to solve equations, and some of the equations will have fractions in them. So it's important that you know how to add the fractions, how to subtract them, how to simplify them, anything there is to do with fractions. We're also going to learn about converting fractions into mixed numbers when they're improper, etc. But that'll be in another video. We're going to start by reviewing how to reduce fractions. Here I have an example, 2 over 6. And what I'm asking you to do is to simplify this, which means to find common factors between the numerator and the denominator and use that common factor to simplify the expression. So let's go ahead and do it. 2 over 6. This is how you do this. You take the numerator. This is what I do. You take the numerator and you're going to make a list of the factors for 2. And what are factors? Factors are numbers that you multiply together to get 2. So what numbers do you multiply together to get 2? Well, I always start off with 1. 1 times 2 will give you 2. What other two numbers that you multiply together and give you 2? There are no other numbers. So the factors for 2 are, we can make a list of all the factors of 2 are 1 and 2. And that's it. Now let's make a list for the number 6. What are the factors of 6? That means what numbers do I multiply together to get 6? I always start with 1. I know 1 times 6 gives me 6. So 1 and 6 are factors of 6. I also know that 2 times 3 will give me 6. So 2 and 3 are factors of 6. And I also know that 3 times 2 give me 6, but I already have those 2 factors, so I'm not going to repeat them. Also, once I hit that number, that I start repeating factors that I already have, that means that I'm done with the list of factors. That means there's no more factors once you start repeating them. So the list for the factors of 6 are 1, 2, and I like to write them in order, 3, and 6. So what I do is I go down this way and I write them in order, and then I go up this way to write them in my list. Okay? So there you have the list of factors for 6 and the list of factors for 2. Now I'm going to look for the common factors. Common factors are factors that are in the list of 2's and also in the list of 6. So what are the common factors? For 2 and 6, we'll notice all numbers will always have a common factor of 1. That means they both share 1 as a factor. And in this case, 2 is also a common factor. Now, out of the common factors that I have on my list, I will choose the greatest common factor. Greatest common factor. Out of these 2 common factors, which one is the greatest one or the biggest number? The greatest common factor, and we also going to see that as JCF, greatest common factor, is 2. 2 is the greatest common factor. This is the magic number we're looking for. What are we going to do with this number? This tells me that the number 2 and the number 6 both have a factor of 2. So that tells me that I can divide the numerator by that magic number, and I can divide the denominator by that magic number. Okay? And in the numerator, I get 2 divided by 2, which is 1. And in the denominator, I get 6 divided by 2, which is 3. And there is your answer. And what this means is that 2 out of 6 is the same exact thing as 1 over 3. It's just dressed up differently. Okay? If you don't believe me, you can go ahead and grab a calculator and divide and hit the keys. 2 divided by 6, and you're going to get a decimal approximation. It's going to say 0.3333 forever. And when you hit 1 divided by 3 in your calculator, you will also get 0.3333 forever. So that means that 2/6 is the same exact thing as 1/3. Okay? Now let me show you a visual of this. Let's say I have a rectangle like this, and let me copy this rectangle and make a copy that's exactly the same as this one. There. In the top rectangle, in the top one, I am going to model 1/3. Okay, so that means I will break this rectangle into thirds. This number in the numerator tells me that I have 1 out of 3. So I'm going to divide this into thirds. And excuse me if this is not perfect, but there. I've broken this rectangle into thirds. And 1 out of 3 would be shading this little piece here. This represents 1 out of 3. Now I have the same exact rectangle here, and I'm going to model 2/6. Now 2/6 tells me that I will break this rectangle into sixths, or 6 parts. So this is what I'm going to do. I'm going to break it into thirds, and then I'm going to break each third in half. Okay? So here I will have 6 equal pieces. There you go. You have 1, 2, 3, 4, 5, 6 equal pieces. Now 2 out of 6 would be shading. Let me choose another color. Shading 2 pieces out of the 6 pieces. And this would represent 2 out of 6. Now notice that 1/3 and 2 out of 6 is the same exact amount. You see that if this were a chocolate bar? It's still a third of the chocolate bar. Even though I took this piece and broke it into 2 parts, that would be represented here. So that's why a third is the same thing as 2/6. And I can write 2/6 as 1/3, and I will not change the amount. It's still the same amount. I hope this visual has helped you visualize why I can say that these two things are equal. Let's do another example. Let's say I want you to reduce this fraction to lowest terms. This also means to simplify. So what do? My first step is take the numerator and make a list of all the factors of 3. And that means all the numbers I multiply together to get 3. For 3, the only 2 factors are 1 and 3. So I'm going to make a list of all my factors for 3. 1 and 3. Let's take the denominator, which is 9, and make a list of all the factors. I know 1 times 9 is 9, and I know 3 times 3 is 9. So that's it. Now I make my list for 9. I know 1 is a factor, 3 is a factor, and 9 is a factor. Notice I went down this way and then went back up this way. I don't write 3 twice because 3 is 3. Why would I repeat it? So here's my list of factors. Now I'm going to find the common factors. What are the common factors here? Remember that 1 is always a common factor. So common factors are 1 and what other number? 3. 1 and 3 are the common factors. What is the greatest common factor? Well, out of the two common factors, which one's the biggest one? 3. So 3 is my magic number. This number 3 is the number I'm going to use to reduce 3/9, and this is what I'm going to do. 3 over 9, and what I'm going to do is I take the numerator and the denominator, and I divide both of them by the greatest common factor, which is 3, by this number. I use it to divide the numerator and the denominator. In the numerator, I will get 3 divided by 3, 1, and 9 divided by 3, 3. So I've reduced the fraction to lowest terms. That means that 3/9 is the same thing as 1/3. Okay? And if I were to draw a visual of this, if I have this rectangle here and I make a copy of it so that I can have 2 of them and bring this over here, okay? Here's what I'm going to do. I'm going to divide this into thirds. So let's say this is 1/3 and this is, right? 1/3, 2/3, 3/3, and shading one of these squares represents 1 out of 3. Now I'm going to take the bottom one and divide into 9ths. So first I'm going to divide it into thirds. I'm sorry for the squiggly line. And then each of these thirds I'm going to divide into 3 parts. So let's see how this goes. Here's 1, 2, 3. And in total I will have 9 little pieces. Okay? So this is what I'm saying. If I were to shade the corresponding parts, I had 3 out of 9. So 3 out of 9 would be to shade 1, 2, 3 out of the total of 9. This would represent 3 out of 9. But notice that for both pictures, notice this. 1/3 here is the same exact size as 3/9. Do you see that? It's the same exact amount. So that's why they're equivalent, and that's why I can write one as the other. So I can say 1/3 is the same exact thing as 3/9. Okay? And when I want to reduce, that's what I'm doing. I'm taking it into lowest terms. And I am able to put this in lowest terms because I'm dividing by the greatest common factor. If you divide by any other common factor that's not the greatest common factor, you will not reach lowest terms. And we always want lowest terms. So I'm going to stop here for now. In my next video, I will give you more examples on how to reduce these fractions, and I will also give you practice. So please watch the next video. I'll see you there.